So the asset administration shell is, of course, a core element, technical element of Industry 4.0. It's been developed and is being developed by the German Plattform Industrie 4.0 initiative, and is also now becoming a standard. Okay, the standard 63278 as part of the EIC TC 65 and working group 24. Okay, what happens is that AAS has started to get much more attention recently. Due to the endorsement and adoption for several industrial stakeholders like Bosch, like Festo, developing more and more the technology, but also the availability of supporting technologies to facilitate its use and integration. So more and more tools, more toolkits, more availability. So it means that it's much easier now to start to adopt and use the technology. Okay. About some funding opportunities, interesting. It's interesting that the AAS and digital twins in manufacturing is explicitly mentioned in Horizon Europe CL for 2021 Twin Transition 0108. If you go read the text, the latest has been shared by the Commission just a few days ago. It's explicitly mentioned AAS in the text, so it's something that it's really required. But also is a thematic area in the AR-Reg open call #1. So you go online and see that it's open, this open call just now, and digital twins and AAS are very welcome there. So funding opportunities for you to work with us with the project on this thing. Okay. So the agenda, going fast now for the actual thing. So basically we'll have today 4 speakers. Okay. So we have Andreas, that will be talking about the actual fundamentals and the new things, and also some demos, the AASX demo, but maybe even more. Then we have Giovanni, that will present an execution environment for AAS. Okay, so the Nova AAS, been developing inside of the PROPHESY FOF9 project. Then Sadia will present work that has been done in this project, the EIT Manufacturing CanVAAS project for connecting assets interoperability framework via AAS. They are using basics in this project, so it will be interesting to see what they are doing there and how they're taking advantage of AAS. And then Liliana from Fraunhofer will talk about the asset notation shell projects and initiatives that they have, and especially also interesting the link to IDS, okay, to the IDS connectors and the IDS data spaces. So it'd be nice to hear about this, and of course there will be some time at the end for some questions and answers. Okay, so I will not take any more time because I think you want to listen to the people that really matters. So I'll give the floor to Andreas. Okay, Andreas, you can take the screen and I will stop. Okay.
So thank you very much, Pedro.
It is okay.
So I hope you see my screen now.
Yes. All okay. You can.
Okay, great. So welcome everybody. So first we will take a general look on the AAS, and then I will also show some practical things on it. So I'm Andreas Orzelski from Phoenix Contact, and I'm in various working groups of the Platform Industry 4.0, which Pedro mentioned, and especially in the working group on asset administration shell, and also in the joint working group on security. I'm in standardization on the German side, but more importantly, in the working group 24 on the IEC side. Pedro is also part of this working group. I'm in the board of the Industrial Digital Twin Association and open source organization, and also one of the maintainers for the open source for asset administration shell for the Package Explorer and for the AASX server. The asset administration shell, the name comes, and probably most of you have seen it from this picture here. So we have the asset, which is the real asset somehow, a device or drive, a robot, a machine, whatever, a whole plant, a whole factory. And then we have the related digital twin, which is the asset administration shell. And also asset is really very general. It's not necessarily something physical only. So it depends on your business. So it might also be a document or a contract. So an asset might also be something immaterial. And the AAS is the specific means, the specific technology developed by Industry 4.0 to create digital twins. A lot of people worldwide have already realized that by the AAS technology, of course, you can also develop other digital twins. So it's not necessarily only the ones for Industry 4.0. So, but it's somehow bound together because it was developed this way. Interoperability, of course, is a key issue. So it's not only enough to have general concepts which are the same. So really the models, the interfaces, the security must be exactly the same to achieve interoperability. It's not only for cyber-physical systems, so for intelligent products, it's also for non-intelligent things. So it can be a DIN rail or a connector or maybe even a screw. So for every asset, for everything, a digital twin, and this means an asset administration shell is needed. And we look on the whole life cycle. So from the product idea of a facility through the development of it as a type, through the production and producing instances, to the end that the product becomes trash. So the whole life cycle is part of the model. And by doing so, over several companies, several business partners, we are integrating value chains, and we are creating the digital basis for new things. This is what we are somehow really looking for, so that we can put autonomous systems and AI on top of all these interoperable activities and technologies. There's a bunch of specifications. So in the core, you have what is called details of the asset administration shell. There we have the part 1 with the so-called meta model, so where the model is explained, also with mappings to XML or JSON or the package format. And there's the part 2, the API, where server APIs are defined, which are interacting. As an entry point, there is the AAS reading guide. If you are new in this topic, I really appreciate if you look on this first, because there, depending on your viewpoint, you will have an introduction which documents to read first to get an easier entry. Very important is the concept of submodel. We see this in a minute, like technical data, like nameplate, like documentation, like operational data. And there's certain submodel specifications, standardized submodels already released. This is also mentioned in the reading guide. And we have just recently come up actively with the IDTA, with the Industrial Digital Twin Association, where again you find a lot of things to get an easy entry to AAS. So let me open this website. I think you should take a look on this. We will not look now. I'm just scrolling a little. So again, you see the reading guide here. You will find the members of the IDTA, which is quite growing at the moment. further downloads and details, a link to the open source. So it would be good if you enter this. There's also a YouTube channel by the IDTA. Unfortunately, for the moment, a lot of stuff is German, but I tested by myself. This subtitle and automatic translation of YouTube is quite nice. So I think this is also a good possibility. You get the slides later on, and I put the links here on the slides to make it most easy for you to enter. So as I mentioned earlier, there's the AAS on top, let's say, or as the entry point to everything. And then we have quite independent submodels. Maybe it's a little too small for you on the screen. So here in identification, for example, you have manufacturer name, or you have manufacturer ID, serial number, technical data, maybe max rotation speed, operational data would be real rotation speed, and documentation would be the document, but also metadata around the document, to give some examples. This is from Asset Administration Shell Part 1, a very basic overview of the meta model. So again, you see here, you have the Asset Administration Shell, then you have information about the asset itself, most importantly, the ID, which could also be on a QR code or RFID in the asset or on the asset. Then you have the submodels, and in the submodels, the submodel elements, and there's a bunch of these elements here. Most important, the property, but you can also have files and blobs and ranges, references, relations, even operations to start a motor, so also to do active things. You can qualify it in the model with additional information, and everything is linked to a data dictionary or an ontology, what we call semantic ID. Yes, and such a semantic ID, very often you have some data, let's say, with a name and a value, but you do not really exactly know what it is. Also in artificial intelligence for the data miners, this is always a big issue to find out what data which you can see in the data mining really is. And this is where the semantic ID comes in. So if you just have the value, you don't know, is this kilohertz or volt or euro or what? And there comes the dictionaries and ontologies in. One major one used, this is the one here with 0173, this is E-class. So E-class is an association with the big data dictionary, also the IEC CDD or the ISO, they also have such data dictionaries. And with the flexible concept of semantic ID, you can also use other ontologies like Web of Things or so. And the meta model also includes security. So I put this screenshot here of that part of the model. So it's included from the very beginning. So you can define roles, you can define attributes, you can define rules. So this is based on ABAC, on attribute-based access control, the model of security in the AAS. For the part 2 API, as I said, there's this released spec. And just right now, to be more precise, yesterday, we put the Swagger for the REST API to the review on the German side. So very soon this will be completely public to the outside. If you search for it, you will find it already. So so this is also a good step that this now comes into standard, let's say. So Pedro mentioned there is a lot of implementations already. So far, there is a kind of dialects in the REST API, but with this version of the API, all the different implementations will exactly speak the same language on this REST level then. There's open source. Also, the other colleagues, the other speakers will speak about the open source. So I'm personally involved in this part of open source on the GitHub admin shell IO. So this is the place where also the AAS Package Explorer comes from. So the AAS Package Explorer is a tool to create asset administration shells, an editor to create it. We will also see it in a minute. And here on this place, you get both. If you really want, you get all the source code. But maybe more easy, you also find the releases here. You can simply download it and use it as a tool to make first steps or to change IIS, whatever. And also here on the admin shell IO, we find the AASX server. We will see some of them. And also for the security, there's a ready-to-use OpenID identity server. And both these servers are also available as Dockers as an easy entry. For the editor, for the Package Explorer, there are many screencasts. Also for the security, you find a screencast in the YouTube, and you find further more deeper screencasts here on this screencast section. Okay, let's now go for some examples, for some example server. So this is one example. You see here AAS from various suppliers. So for example, from Festo, from Bosch, of course, from Phoenix Contact, from Schneider, Pepper and Fuchs, and others. And the beauty of this example here is that for certain submodels, you can already see here how the future will be if all the data is in the same format. So for example, for the nameplate, there's a standardized nameplate, and then of course you have company-specific, supplier-specific information inside. But if I open the nameplate of another one, you see it's the same structure and only the specific data is different. Again here, this concept description comes in. So here you see the E-class ID because things like manufacturer name could be different or could be in the national language, but still internationally by the semantic ID, the IT systems will detect everything correctly. So with AAS, the IT software will basically use the semantic IDs for the business logic and no more the names, which could be ambiguous. And looking maybe for another example, documentation. There is a standard which was developed in Germany by the VDI, association 2770, and there you see you have the file itself, which is for us as humans, but then there is a lot of metadata around it saying which type of document this is, in which language it is, the version or the date. So here the classification as a number or as a name. So these kind of things in the submodels. Let me just check. And this server not only has this interface for us as humans, but more importantly, it has an interface for IT systems. So calling the REST API of this server in the most simple way, we just ask what are the AASs on that server. In a more detailed way, we would ask for a certain submodel or for certain properties in a submodel. So all this can be easily done by the REST API. And also by this API, we may now connect to the server by the editor. Of course, I can open AASs here from the file system and send it as files, but more nice and more powerful is to do it by servers. I will connect to that server, which we have just seen in the web browser. And first of all, we retrieve the directory, similar as we did in the browser. And now the Package Explorer will show us the same AASs again, which we had before. And this server also includes the security, as I earlier mentioned in this example. And for the first AAS, we are allowed to retrieve it as an anonymous user. So you see the download here on the bottom. Everything is behind my Phoenix Contact VPN, firewall, and proxy. Also, this is an important thing, that the technologies are qualified and verified to work in real IT systems. So this is also part of our work to make this happen. And you also see here in this AAS, there's the security meta model included. And yeah, this is a little, let's say, hard to read. So because it's here really with the meta model. But let's open one of the rules here. So we are saying if a user is not authenticated, so an anonymous user, then to this user for the AAS itself, so it's this AAS here, we give the permission to read and the permission to update and an allow. We could also have rules with deny. So it's a little complicated from the structure, but after some learning, it's somehow easy to read. And for the other AASs, they are not configured this way. So you need to be authenticated. So I do a double click here. And now I'm redirected to the OpenID server. And with just a moment. I like my mouse here. Okay, it's back. Sorry. I want to show this picture. So we are redirected. So we have entered this server. We could open data where we don't need authentication, but once we open something where we need to authenticate, This can be a complete AAS, this can be a submodel, this can even be a single property. Then we are redirected to an authentication server. This is explained in the document Secure Download Service. You will have all the links here on the slide. And then by this server, by X509 certificate chains, which I already have on my computer, we have a very powerful way to authenticate connected with OpenID. And by putting a root certificate there, for the moment, all members of Phoenix Contact, Bosch, Festo, and some others can easily authenticate on that server without any further configuration. So let's simply continue this. So I'm asked for a certificate, and this is my normal user certificate, which I got as a member of Phoenix Contact. This is sent then as a certificate chain to the authentication server, and then we get an access token back, and by this access token, the authorization on the AAS server is done, and I get my data back. Okay, so that's it so far for the security demo. And now finally, let's go for one more server. So this data of AAS is not only static. So this is a common misunderstanding that people think, some people think this is only for product data. No, of course, we saw before we had this submodel for operational data. And here we have another example of a server where we have live data, in that case simulated. I also have a PLC on my desk, but I didn't connect it. So you see here is data. This data is collected as a time series, and also in the AAS meta model, there's what is called events. And this live data collected on the server, we can also connect to by the package explorer. And this is the last thing what we will do in my presentation. So I will now connect to this server here. Let me just grab the name here. And there's only one AAS there. And in the package explorer, to be honest, this is very new. This feature, you can now click on Stay Connected here. And if you open the AAS, you will see the live data also here in the package explorer. And once here 20 is reached, we will see here for the data that the new collection was just created and another one in the end was deleted. And the nice thing here really is that this is done by the AAS events. We see this here in the event log. There's two kinds of event. An update event simply says when values are changing. And more interesting even is this structured change event, where we get events from the server when a collection is deleted or created. Okay, so this is all from my side. Yes, to give you an overview, partly about the theory behind it, but also some practical things around implementation, including security with the admin shell IO content. Thank you very much.
Okay, thank you very much, Andrea. It was really, really great and easy to follow and quite practical. So now we give the floor. By the way, so we will have the question and answers at the end, right? So I will give you a floor for everybody that wants to ask questions, and I'll give you even open the mic and you can ask yourself and can interact. So all on to them. We can comment and discuss during the chat. But now I'll give the floor to Giovanni. Giovanni, he works with me at Uninova, and he is doing an execution environment for AAS, which is quite interesting. He will present. I'll not go into much details because he will tell all about it, okay? When you can take the floor.
Yes. Thank
Yes,
you.
We see you, so okay.
Let's share the screen. Yeah.
We see the screen, okay.
Okay. I think you can see the present. Can you see the presentation?
Yes, all okay.
Okay, my name is Giovanni Diorio. As Pedro already said, I am a research engineer at Nova School of Science and Technology. I am basically the main developer and also software architect of the Nova Asset Administration Shell. Before starting the presentation, it is a demo-oriented presentation. I'm going to show actually the technology working. However, before starting the presentation, I want to give you some context. Basically, the first question is, what is Nova AAS? In the previous presentation, we have seen the AASX Package Explorer. This is a tool that allows you to model, to create an asset administration shell that basically in its simplest form, it is actually an electronic description of a physical asset. However, when you have this electronic description, you want to connect this model, the model that you have created, you want to connect to a physical assets. And how you can do that? Actually, the asset, the Nova AAS, is actually this. It is an execution environment that allows to you to connect models, the administration shells that has been modeled by using the AASX Package Explorer and to connect these to the physical assets. So basically, the Nova AAS provides a server. So an API that allows to you to get to query the model and also to get data by using the model and to connect the model to the physical asset and retrieve data. And it also provides a viewer for the AASX packages. The second important element is that Nova AAS provides all the necessary mechanisms that allow to you to connect an AASX package to a physical assets. So by using the Nova AAS, actually you can retrieve data from the physical asset by querying a generic model that is the models that Andreas showed in the previous presentation. The difference in terms of the technological difference is that we are using to implement Nova AAS, we are using a paradigm that is low-code, low programming paradigm. So actually we are using technologies like JavaScript, JSON, REST, MQTT, and so on. And another important difference is that it is designed to be cloud native. What does it mean? It means that it is designed actually to be containerized and also to be orchestrated by tools and infrastructures like Kubernetes. In the specific case, K3S is the Kubernetes distribution for the small devices like Raspberry Pi. So this is the features and capabilities on NovaAS. Actually, this is the architecture. We can see that basically we have a southbound interface that is the component that is responsible to ingest data from the physical assets. We are supporting here different protocols like in the transport protocols and so on, HTTP, MQTT, Kafka, OPC-UA, but we also have Modbus and so on. After there is the NovaAS core that actually connects the model, the generic model, to the specific data provided by the physical assets. And on the top of this architecture, we have the northbound interface that is actually the data streamer. Actually, this component is responsible to push data outside NovaAS. In this case, we are using MQTT as a technology, and the events are modeled by using, according to the specifications from the Industry 4.0 documentation and so on. We have also a user interface that allows you to query the model and also to have a look at the data that we can retrieve from the physical assets and so on. So this is more or less what I have to say. The background, the presentation. I will try to follow these steps. So I will first of all I will show the repository that contains all the necessary files to instantiate NovaAS. After I will show you the front end. A little bit. I will show you a little bit the back end of the technology of the application. After I will show you two different instances of NovaAS, and at the end of this I will show a client application that actually get data from NovaAS and actually create dashboards by using this data. So this is more or less the demo playground. What I have, everything is now instantiated in my computer. However, I have a technology that is multipass that allows you to create clusters of virtual machines. I am now running 4 virtual machines, Ubuntu virtual machines, and on the top of these virtual machines, I have Kubernetes, K3S, and Docker that allows me to containerize applications, but also to orchestrate different applications. On the top of Kubernetes, I have 2 different virtual clusters. One is the so-called Industry 4.0 information bus that is actually contains instances of NovaAS and an MQTT broker that allows to each instance of NovaAS can publish data to the broker, and any client application can retrieve data, can subscribe to these topics in the MQTT broker. Within this bus, we have also an access management server, identity and access management server. So a client application, in this case, whenever they want to use data from NovaAS, they have to, this client application has to authenticate against the management, the identity and access management server, and after they receive the token and can connect to NovaAS. It is the same as Andreas presented before. However, I am not connecting to an external identity server. I have one running in my computer. And finally, another virtual cluster that is the monitoring part is actually the another client application that get data from the broker and create dashboards. So once given the context, I will show you the technology. So let's start with the repository. In GitLab, you have a public repository for NovaAS. This repository contains all the files that are necessary to run an instance of NovaAS. We have here all the information that you need to know to start NovaAS. You can start it by using Docker, you can start it by using Docker Compose, or you can also by using Docker Compose. Or another possibility is to run directly a container. This repository has an associated container registry, and you can see here that you have actually images. You have images, and these images can be downloaded and deployed in a Docker environment. So in terms of files, we have a script that allows you to have a continuous integration, continuous development pipeline, and what you need actually is this model AASX. This model has been created by using the AASX package explorer. It is actually the description of the physical assets by using the specification from the platform for Industry 4.0. So once you have this model, if you put this model within this folder and run the Docker commands, you will create a specific instance, an instance of Nova.js associated to this model. So as an example, I can show you this one. So this is, for example, instances of Nova.js for a temperature, for a simple temperature sensor. We can see that we have here, we do not have any information because we have to authenticate in order to retrieve information. If I want to do that, I can log in, and this login is actually what I am doing is asking to the identity and access management server to have a token in order to get the information from the API. So now we have all the information that we need, that actually Nova.js has regarding this temperature sensor. We can see here the description of the asset administration shells that we have. Actually, we have an asset administration shell for the temperature sensor, and we have also an asset administration shell that manages the security server. Actually, this asset administration shell contains the security models that are necessary to protect the Nova.js API. These models are standardized models, as also Andreas presented. I only adapted a little bit the models in order to connect to a K-clock identity and access management server that is a little bit different from the OpenID server, but the logic is exactly the same. So we can see that we have the authentication server, the endpoint, where is the endpoint, where is the discovery document, the rules that are available for these for the asset for Nova.js. In this case, I only use one rule, that is the authenticated organization. So in this case, we are only authenticated organization are able to use the Nova.js API. Okay, this is one element for concept description. So this is the description of the environment. For each one of the submodels, we have also the concept description. This is for the semantic. So everything is connected by using these IDs, and we can actually describe each one of the elements within the submodels. This comes directly from the AASX model. So all the models that you created with the AASX package explorer is actually presented by Nova.js. Now, you can actually also create some dashboards. I will show you how Nova.js can actually present data, internally present data, and you can also have a reporting section that allows you to create reports about the status of Nova.js, and this is more or less what I have to say for this instance. I have another instance that is running. It is for another physical asset that is a Festo cylinder. The concept is exactly the same, so I can again log in. I have to log in within the system. In this case, within Nova.js, I have So I can log in, and also in this case, I can see here, for example, the elements that I can query actually the models. For example, I have these submodels for these physical assets. As also Andrea presented, we have standard submodels like the identification submodel, the documentation submodels. So, for example, for the documentation, we want to retrieve we want to retrieve the data sheet, the operator manual of this physical asset. I can get this file, and I will get there the link to the file, so I can show this is the documentation related to the specific physical assets. But to the specific physical asset, for example, if I want to create, in this case, a dashboard, it is very easy to do that. So I can create a test dashboard also, and associate this dashboard to a data source. In this case, valve position, that is one of the elements that I can get from the physical assets, and I can actually start to select the type of the visualization, the X and Y axis, and so I can actually start to plot the status of the valve in this case. It is the same. Actually, I can create several dashboards, but these are only for live data. If I want to actually present or to analyze historical data and so on, the NovaIS at this moment doesn't allow you to do that, because there is no a database associated to NovaIS. For this reason, we can use an external client application that store the data from NovaIS and plot this data. I will show you also this client application, how we can do that. As for the reporting tab, so we can actually also create reports about the status of NovaIS, and we can download. Actually, we can always see the status of the NovaIS, how many messages I am receiving from the physical assets, how many information channel we have, if we are connected to the physical assets, how many times someone logged within NovaIS, and also the last queries that we have done within NovaIS. So this is for the static information, but the problem is always the same, how we can actually stream data outside NovaIS. To do that, actually, we can we are logged in within NovaIS, and we can look at the operational data submodel. This submodel contains all the data that can be that are dynamic data that changed along the time. So are these data, and for example, if I want to observe these elements, what I have to do, I have to select the elements and I have to observe them. I will receive several logs. I can check. So the logs, what is there is that has been created a data flow. Actually, NovaIS is opening a data flow from the physical asset to the outside world, and we can see that we have these elements that have been subscribed. So these variables, actually response time, valve position, response time, moving average, the status of the cylinder, and so on. These are elements that now NovaIS is publishing within the MQTT broker. So if I have a client application, that is the case. For example, this is my client application. I can see that I am receiving data from events from NovaIS, and I can see here the topic of the event. In this case is the status of the cylinder, the timestamp, and the values that I am receiving. Now, on the top of this connector, I have a client application that is ThingsBoard, is this one. this platform allows to me to actually is a platform that allows to manage a little bit an environment with several NovaES. So I can create a device, a virtual device that is associated to NovaES, and I can actually create a topic associated to this virtual device. So we can see that once I subscribe the variables, I will start to receive all the information that I need. So we can see that if we want to create actually a dashboard, we want to see these variables along the time. That's only. We can see that we can open the dashboard. We have a dashboard associated. So we can open the dashboard and we can start to analyze the data. So these are live data that NovaES is now publishing within the MQTT blocker, are the data that I have decided to, that I subscribe. And we can see that actually this is the status of the variable, of the valve. This is the position of the cylinder. In this case, it is 0, that stands for close. And this is the response time and the moving average. In red, we have a prediction of the future response time of the closing time of the valve. It is actually calculated by NovaES internally, so we receive only raw data, and NovaES is creating a second order function that calculates this prediction time. So this is the client application. As I told you, everything, NovaES has been designed to be cloud native. It means that we want to be able to work with Docker and Kubernetes. This is the environment that Kubernetes, the environment that allows to run NovaES. So as I told you, we have two virtual clusters. One is the information bus. Within the information bus, we have a broker. We have the identity server management, that is Clock. We have NovaES, two instances of NovaES. One is the fast and the other one is the temperature sensor. And actually what we can do there, we can we can change the way to deploy the application. So we can actually associate a new port. We can change if in this case it is not replicated, but we can replicate the service over the cluster in order to avoid the single point of failure. But we can also do other stuff. In specific case, we can create a pipeline, a continuous integration, continuous development pipeline, because this tool is now connected to the to this repository. So whenever I change this repository, an image is created, and this image is automatically pulled by Kubernetes and deployed. So whenever I change something, I will always have in my cluster, will have the last version of NovaES. So this is more or less what I have to say about NovaES. The last thing is the NovaES backend. This is how NovaES looks like. It is actually a graphical environment. NovaES, the logic of NovaES is actually presented by a flow. Everything is there, so you can see that we have the component manager, we have the northbound interface, we have the southbound interface. Everything is graphical. Why we are using this? We are using this because actually in the industry, most of the time the industrial controllers are PLCs that are actually programmed by using a graphical language that is ladder logic, and it is very they want to use this kind of representation because it is very easy for people that has no no technical skills, let's say no programming skills, to debug the system and to understand where is a problem or not. and so on. So graphically, it is very easy to identify a problem. You can see the messages here. You can see everything is presented here. If you have a problem, you can actually link where the problem is and so on. So it is very easy for people that has no programming skill to take this code, this logic, and to understand what is going on. So for this reason, we are using this kind of representation. And another important element is that if I want to change something in this code, I can do that. It is a matter to configure. For example, if I want to configure my HTTP client, I can do this by configuration and not programming. So I have no, actually, I do not need to program anything. However, and whenever I change something, if I want to change it from a get to a post and so on, I can deploy the change on the fly, and this change will be available on the server. So I don't need to compile again the software and so on. So it is we can actually deploy new version of the system in a very short time. And finally, we have, for the ones that want to use Nova.js, we have created a collection that is Nova.js collection. Actually, here we have a project, a group that is from Nova School of Science and Technology. You can see here we have different instances of Nova.js that are working with different, each one with a different flavor. This is the standard version of Nova.js without any security. This is the security that we are, the version of Nova.js that is working with the security server from that Andreas presented, the OpenID security server. But we have also this version that is working with the KCOC security server and so on. So by using this kind of approach, we want to push a little bit the developers to create their own instance of Nova.js, to create a project and deploy a new instance of Nova.js, and actually to create some kind of open source community around this tool. So we have, for example, for FlowWake, we have a specific version of Nova.js that are working with the universal robot ARM, and also for ABBE, we are ABAA. We are actually creating a specific instance that that is working with specific protocols and so on with a specific physical asset. So this is more or less everything from my side.
Okay, Giovanni, thank you very much. Took a bit longer than we wanted, but okay. So Sadia, I can move to you rapidly, and you can present your developments around CanVAAS.
Yes.
You can take the floor.
Do you see my screen?
Yes, yes, yes.
Okay, great. Okay, so hello everybody. I'm Sadia Dweeb from CE List, and I'm the coordinator of the CanVAAS project, where we are implementing the asset administration shell standard as well. This project is funded by the EIT Manufacturing, and there are 6 partners in this project. So 2 from France, 2 from Italy, and 2 from Germany. From the French side, there is CE List and Sherpa Engineering, which is an SME that is working on providing simulation tools for cyber physical systems. And from the Italian side, we have Polimi and Whirlpool, who are providing use cases and demonstrators for the tool set that we are developing in CanVAAS. And from the German side, we have the FKI, who is the second tech provider besides CEA. And FES2, FES2 is providing a demonstrator as well for the tool set that we are developing. So the challenge that we are responding to in CanVAAS is the interoperability challenge, and Andrea has talked about this. As you know, from Industry 3.0 to Industry 4.0, we are moving from the traditional automation pyramid to an integrated network of smart devices, equipments, applications, products, and also smart enterprises. And in this new architectural landscape, we are needing horizontal and vertical interoperability. By vertical interoperability, we are talking about the interoperability about all these layers and the ISA 95. And by the horizontal interoperability, we are talking about the interoperability in the connected world between factory and enterprises. And when we talk about interoperability, we always talk about standardization, and we have chosen to implement the asset administration shell to ensure the interoperability in the Industry 4.0 domain. And so this standard is pushed by the trilateral cooperation, Alliance Industrie du Futur from France, Piano Nazionale Industria 4.0 from Italy, and Industry 4.0 Platform Industrie 4.0 from Germany. And we know that Platform Industrie 4.0 is the main provider of the asset administration shell standard. Okay, so the asset administration shell is part of RAMI 4.0. I will not dive in the details of the standards as Andrea has talked about it. The Industry 4.0, the asset administration shell is providing a digital representation of any asset that you can find in the factory. It could be a product, a field device, or anything in the hierarchy levels that you can see here. And it could be also a component that is in the business layer or the functional or the information layer. So this digital representation that is provided by the AAS is standardized. So every asset will have and should have a standardized digital representation. So this asset could talk with another one in a seamless way. And an I 4.0 component, which is the asset plus its administration shell, could be a type. So it could be designed, and we consider it at the design time, but could be also an instance. It could be a product or a running equipment. Okay, so what is CanVAAS? CanVAAS is an open source implementation tool for the Industry 4.0 asset administration shell. I am saying open source, but it is not yet publicly available. We are scheduling the Eclipse migration of our source code for December 2021. And now all our developments are available in internal CEA Git servers. And the name of the component that will be in the Eclipse platform is Papyrus for Manufacturing. So it will be a subcomponent of the Eclipse project. Papyrus is already an Eclipse project, and CanVAAS developments will be a subcomponent of the Eclipse project Papyrus. So, and CanVAAS is based on not only on Papyrus, but it is based on also on another open source tool, which is Basics, and it is an Eclipse project as well. So I will explain you later the usage of Papyrus and Basics in CanVAAS. And we aim in CanVAAS to validate the asset administration shell standard by implementing it and testing it on several demonstrators that are provided by our partners, which are Polyme, FS2, and Whirlpool. Okay, and the standard communication protocol that we are using in CanVAAS is OPC UA for now. So we don't have support for MQTT, for example. Okay, so this is the whole picture of the CanVAAS toolset. As you can see at the upper side, there is Papyrus, and at the bottom side, there is Basics. So Papyrus is used to model, design, and deploy an AAS component. So in Papyrus, we are providing a graphical user interface. It is like the AASX package explorer, but more graphical and more systems engineering oriented. So in Papyrus, you can model your AES component or several AES component, and you can model the interaction also between these AES components. And then you can generate code for your AES components to Basics. So Basics is the runtime infrastructure for our AES components. And once we deploy, so we generate the code and deploy it, the AES component is running and is communicating with the actual asset using the OPC UA protocol. And also we are aiming to implement all the monitoring stuff. So how to get real-time data from the assets, analyze them, and then how to perform simulations and validate some properties before redeploying a system or redeploying a reconfiguration of a production line, for example. And for the simulation side, we are using the tools from Sherpa Engineering. Okay, so as I said before, we have two industrial demonstrators, one from Festo, one from Polyme, and one educational demonstrator. The industrial demonstrator are from Festo and Whirlpool, and the educational demonstrator is from Polyme. Okay, so this is a more technical slide, and it is about the technical architecture of the tool set. As you can see, there are three tools: PhiSim, which is the simulator from Sherpa Engineering, and we have Papyrus, which is the design tool for the AES components, and we have Basics, which is the runtime environment for the AES components. And Basics is ensuring the communication with the equipment through the OPC UA protocol. And all these tools are communicating through the REST API, which is provided by Basics. But for now, this REST API is not yet conformant to the part 2 of the AAS specification, which Andrea presented before. And we are working on the conformity to this API that was published, I think it was 6 months ago or something like that. Okay, so this is the technical architecture. So we design the AES components, we deploy them to Basics. Basics is running the AES components, and we can monitor the execution of these AES components. We can send back data to PhiSim, which is a simulator, and we can run simulations. We can feed these simulations with some runtime data, and we can take decisions before redeploying, for example, a new configuration of the system. And we are also working on a communication between Papyrus and PhiSim. Okay, so regarding the Festo demonstrator, so it is based on the Robotino robot, which is provided by Festo. And so it is a very, very simple demonstrator. We have the Robotino, we have a manual workstation, we have a material storage, and we have a server for the AES components. So, and each, the Robotino is composed of AES components, and all these AES components that you can see are communicating together. So this demonstrator is aiming at validating the AES standard, and Festo are modeling their demonstrator using our tooling, so the implementation of the AES standard in Papyrus, and using Basics as well. And we are in a very close communication with them to get their feedback on the tooling, on the ergonomics of the tools, on the features, and we have a very close communication to enhance what we are developing by having the feedback from the demonstrator. Okay, and regarding the Whirlpool demonstrator, it is a really different one because it is a huge manufacturing production line from Festo. It is a drum line with hundreds of components, and the modeling of this production line is very different from the modeling of the Festo demonstrator. So here Whirlpool are working on the methodology that they should follow to model their production line. What is the granularity of the components? What some models should an ACE component contain? What are the properties that should be in the submodels, etc. And it is a huge work for them. Yeah. And there is no deployment here, so it is just modeling for the Whirlpool demonstrator, and we are validating the modeling toolset with them. So it's like with Festo, they are testing the tooling, modeling their production line using the tooling, and they are giving us feedback. And regarding the demonstrator from Polyme, it is an educational demonstrator. So it is a small production line from Festo as well. And so they are working together with Whirlpool on a methodology to model this production line and what should be the components of this production line, what should be the sub-models inside this production line. And they are working on a library of sub-models to be reused from one production line to another. And also they are validating our tooling through the usage of the tool set for their production line. Okay, so now I will give you just a view of the tooling which is implemented in Papyrus. So as you can see here in Papyrus, there is a model explorer to show the content of the model. There is a project explorer, and here you can have all your projects, and there is the diagram view, and in the diagram view you can create a graphical view of the content of the model, and there is a palette to create components in your model. So you can create the AAS, you can create the assets, you can create the submodels, you can create the relationships between them graphically. Okay, so we have a package of assets here, and we have the set administration shell. So for each asset, we can create one or several administration shell. And inside the administration shell, here you can see the submodels. So to create a submodel, you right-click on the asset administration shell, and you choose create submodel, and the submodel will be created here. And then you can have a graphical view as well for your asset administration shell. This asset administration shell is linked to this asset, and this asset administration shell is containing 3 submodels that you can see here in the diagram. And we can also model capabilities of an equipment. So for example, here we have a production cell, and we can model the capabilities, the provided capability of a production cell. Capability is a concept coming from the asset administration shell. And we are using the property value statement standard as well to model what is a provided capability and what is a required capability from an equipment. So provided capability for an equipment and the required capability from a production process. And we can model also the skills of an equipment and how a capability is realized by skills. and skills are modeled as operations inside the submodels. And then, yes, here you can see the AAS tab, the properties view, and in this AAS tab, you have all the attributes that are coming from the standard. For example, here we have the submodel production cell capabilities, we have the ID short, we have the category, the description, the kind, and all these informations are coming from the standard. So we are implemented, we are fully compliant with the standard here in Papyrus. You can see the submodel elements. You can create the semantic ID as well for a submodel or a submodel element, and you can link it to an ontology or to e-class. And also we can create BOM diagram, the bill of material diagrams, to show the composite asset administration shell. So an asset administration shell can have an internal composition, which is a composition of assets. And we provide diagrams to create this composition. And also another important thing that we have here in Papyrus, we have integrated a support for process modeling. For example, if we have an asset administration shell for the process, we can create a process model in the in Papyrus. So this process requires capabilities, and the capabilities are modeled at the level of the process. And we have BPMN diagrams also, support for business process modeling notation to model the process. So here, as you can see, there are lanes. The lanes are the different steps of the process. And in the lanes, there are tasks, and these tasks are linked can be linked to operations that are provided by other assets in the model. And finally, yeah, this is the code generation. Yes, so for each asset administration shell, we can generate the basics code, which is Java code. And as you can see, there is a new project now in the workspace, which is the AS production cell that corresponds to the code generated from this asset administration shell. And there is a README file that is automatically generated, and that will show you how to launch the asset administration shell, how to execute it. And then once it is compiled and executed, so you can copy the address of the asset administration shell that just have been generated, and you can access all the information of the asset administration shell here. And you can use the REST API to get data from this asset administration shell. So you can get the value of the properties of the asset administration shell, or you can also you can set also the properties of the asset administration shell. And you can also call the operations of the asset administration shell using the REST API. Okay, so this is all from my side.
Very good, Sadia. Thank you very much. Very nice work and very good work on the Papyrus. There is a question then, but we'll see if we can have time also to reply to that. So we move to Liliana. Liliana has a lot of nice work done also in this front at Fraunhofer, and especially also linking to IDS. So I can give you the floor, Liliana, or you take the floor. Yes, thank you very much.
Thank you. So can you see my presentation?
It's coming, not yet. We can see you. And now in a second, yes, now we can see the presentation, yes.
Do you see it in design mode or in presentation mode?
Presentation is okay.
Okay. Good afternoon. My name is Ljiljana Stojanovic. I'm head of Smart Factory System and Fraunhofer ISB in Karlsruhe in Germany. Fraunhofer is the largest research organization in Europe, and Fraunhofer ISB is the largest ICT institute within Fraunhofer. I'm leading the research group. Our vision is to bridge the gap between engineering and the operational phase of the production system. And to do this, we base our work on standards. And one of those standards is also asset administration shell. So it is important to mention that we are not only the user of these standards, we also contributed to these standards. For example, regarding asset administration shell, we contributed to Part I, especially for the serialization of our meta model into automation ML. Also, Fraunhofer ISB led the OPCUA companion specification on AAS. Regarding digital twin, we are active worldwide. We are active in IIC. Fraunhofer ISB leads the working group on digital twin, and we are also active in digital twin consortium. There is joint working group between DTC and IIC working on digital twin for system of system. Today I'm going to present our FAST system. This is a set of tools and also methodology to develop IIS compliant digital twin, but we also add some features on the top of the IIS specification in order to make digital twin more intelligent. Before I start my presentation, I would like to clarify the terminology. What are digital twin for us? So we use here IIC definition of digital twins, which is very generic, which said that digital twin are digital representation, which is sufficient to meet requirement of a set of use cases. This is very abstract, very generic, but they said that each digital twin consists of data, model and services. This data should be collected during the whole life cycle of the assets. For the model, we have to have different kind of models, so data-driven model, simulations model, 3D model, CAD model, and also it's very important for this digital twin to have services, and these services have to provide access to data, to invoke commands, or also to run the models. Before starting to implement software for digital twin, we did an analysis of the existing standards for digital twin. We consider asset administration shell, we consider DTDL, this is digital twin description language, which is pushed by DTC consortium. We also consider some standards from IoT community like Web of Things. And based on this analysis, we decided to base our work on the asset administration shell, because this is the only standard which have a strong focus on industry, and we believe this is essential to be recognized and also well accepted and adapted in the real world industrial plants. And the standard also provide explicitly support typical industrial protocols like OPCUA or automation ML. So based on this analysis, we have developed FAST. FAST stands for Fraunhofer Advanced AAS Tool for Digital Twin. This is a Java-based software ecosystem to create and to manage IIS compliant digital twin. It consists of a library for developers to easily create and execute digital twin. This is called FAST service, but we also have FAST registry, which allows to register and to discover digital twin. And we have also developed a set of tools for the domain expert who are not aware about IIS, to be able to create and to manage this digital twin without deep knowledge about IIS. Our software has several unique selling points. So one selling point is that it ensures that we always use the latest IIS specification. We know the IIS is still under development. There are some changes also in the meta model. Some errors are corrected. And we ensure to use the latest version because our model for asset administration shell is automatically created based on the RDF specification of the IIS meta model. The other key features are that our software can be easily extended and configured. Also, we provide support for different models. It was the question in the chat if the IIS can support simulations model. Yes, we are able to provide support for simulation model, but also for machine learning model or deep learning model. And we also provide support for IDS in order to add, to increase the trust level for digital twin. Our software will be made available as an open source very soon. Currently, we are resolving some legal issue regarding name and similars. So this slide shows the high-level architecture of our system. So as I mentioned, it was designed to be easily extendable and customizable. And to do this, we provide a variety of extension points. So our core element is IIS meta model, which represents digital twin with all its properties and services. On the bottom side, you see asset connection extension point. We want to support connecting the IIS to any kind of resources or legal system independently of connection or protocol types. And it is crucial that IIS service library allows for custom implementation of this connection logic. Currently, we provide support for OPC UA and MQTT. On the upper side, it should be mentioned that Platform Industry 4.0 doesn't standardize these connections to the asset, but Platform Industry 4.0 standardize our connection to other software system or to other digital twin. On the upper side, we provide APIs to interact with the digital twin. So we provide protocol and extension point. We currently have implemented the OPC UA endpoint and also HTTP REST-based endpoint. And what is also important to mention, we provide support for synchronization between these two endpoints. So if you send requests or change via HTTP REST, you can see this immediately by using OPC UA endpoint. And here in the middle, you can see handler, or this is our message bus. This is component which is responsible for the mediation and for synchronization between the endpoints. Regarding serialization, we currently provide support for REST, for RDF, for JSON, and also for automation ML. And by the end of July, we should be able to provide support for other formats which were proposed by Platform Industry 4.0. And also there is support for different persistence. Okay. In order to be able to deal with different model, in order to be able to run different type of model, simulation model, data-driven model, we provide integration with the StreamPipe Apache runtime. I'm going to talk about this later. So our goal is to be able to integrate different models into our realization of the asset administration shell. And we know the current standard typically allow representing digital twin only by attributes. But knowledge about behavior of an asset, this is essential to control this asset and also to interact with them, especially in the context of industrial production. And this behavior is typically represented by multiple different models. So it is necessary the digital twin is able to manage this model, to integrate and also to orchestrate the model. What all these models have in common is that they take as an input one property from the asset administration shell, then apply a model on that. Model is in this case some logic, and then they report back the result to digital twin, and it is done by updating existing property in digital twin, or also there is possible to create a new property in the digital twin. And the models are implicitly interconnected or combined in a way that one model can use outputs of other model, or you can see in the example that I have later, for some use cases, there is a need to explicitly combine these models. So the model represents a logic processing step, and to execute model, you need the execution environment. And this environment can be deployed inside or outside of a digital twin. And this decision is trade-off between ability to run digital twin and standalone application, or also to take into account resource requirement, because in the case that you have external modeling, model execution environment, different digital twin will be able to share this environment. So these slides show the generic architecture, how this can be done, and these slides show now the concrete implementation. So what we did, we have integrated file service with Apache StreamPipe via Apache StreamPipe runtime extension. So StreamPipe is used to manage different kind of model. And on the top of this screen, you can see the editor of StreamPipe, the design environment. This is easy to use visual editor, so which should be used by non-expert to create so-called pipeline. Pipeline consists of data source, different processor, and data sinks at the end. So data source fetch the data from external system and fed it to the chain of processor, and data sink can be used to send this result back to external system. What we did here for the integration with the StreamPipe, here you can see in the middle that each pipe has two specialized components. This is a digital twin source and digital twin sink. These two components have been developed by us. And this enables non-expert user to use digital twin as a data source or a data sink in Apache pipeline with just a few links. Currently, Apache StreamPipes is deployed as external component, but we are working on deploying it, on running it inside of digital twin, and we have several develop several operations, for example, to start and to stop pipelines, and maybe in the future we will be able also to modify the pipelines in real time. This slide shows one application scenario from the CogniTwin project. This is this project is about applying digital twin in the process industry. Here we have steel production, which consists of 3 steps. So scrap steel is collected and melted. Then in second stage, molten steel is transferred to this ladle that you can see here on the left bottom part. And then in third step, we have casting process, so molten steel is molded in the desired step. But here we focus on the second step, where we have a ladle with heat resistance brick. However, after each step, after each heating cycle, the bricks are getting thinner and thinner, and the key decision is to decide when to replace these bricks, when these bricks have to be demolished, and when when to place around the inner wall of the ladle the new bricks. And in order to do that, we have several parameters. We have high frequency parameters, which are collected during the process. We have low frequency data, which is collected at the end of each ladle cycle, and we have manual data which are collected after ends usage of data. So the worker have to measure the thickness of each brick and each lever. This data is highly relevant to decide when to replace the ladle, the bricks in the ladle, and therefore what we did, we combined physics-based model with the deep learning model. So physics-based model are used to calculate the values of the parameter that cannot be monitored. In this case, it is the thickness of the brick wall, and then we put this parameter as additional input for deep learning model in order to be able to do prediction with to better prediction. The other extension that we did with our fast system is the integration with IDS. So for data sharing between companies, we need interoperability, and interoperability is supported by Platform Industry 4.0. But we also need data sovereignty. And for do this, we have to take into account IDS. There is IDS industrial vertical community within IDS, which deals about how to bridge the gap between these two different words, and this can be done at the architecture level. We have RAMI, we have IDS referent architecture, we have different specifications. What you can see here is what can be done at the component level, and how IDS connector, which is key component of the IDS, can be combined with the asset administration shell. And here you can see several possibilities. So you can define AAS for an IDS connector, but in this case, the asset administration shell communicate to each other via AAS protocol, so you do not use the advantage of IDS. You can add IDS connector on the top of asset before you send the data to the AAS in the cloud. And what we did, we decided to use the last solution. So we allow AAS to communicate with each other, with other components in a secure and data sovereign way via IDS specification and communication. So our idea here is to continue to use standard protocol and messages of the asset administration shell, but to enrich them with the IDS component. In this way, we are able to increase the trust level and also to control the use of the data. And these slides show how this integration has been done. So for the use and integration of digital twin across the company borders, we propose to integrate digital twins with IDS. So in this way, we ensure security and also confidentiality of the change information. Inside of company, on this side you can see company A, the actor, which can be user or it can be software system, can interact with digital twin by using digital twin API, because digital twin API offer access to properties, to services or event. But if you have actor from outside, in this, what you can see in this slide as company B, then they have to use the IDS API to interact with digital twin, and it is required that both company A and B provide IDS connector, and also this connector and all components within connector have to be certified. The ISO standard 23247 was also mentioned in the chat. So you can, on this slide, you can see the other view on the architecture of our FAS system. This standard defines framework to support creation of digital twins, and it defines the building blocks of digital twins. So we have on one side asset administration shell, which defines the meta model for digital twin and defines standardized interfaces to interact with the digital twin, with the digital twin with the external system. But this standard defines the internal structure of the digital twin, and we analyzed this structure when we created our software, because we wanted to ensure that all aspects are considered, that each building block is well understood, and that this is correctly placed. So I'm not going to talk now about each block. So all these 5 blocks are the blocks that we have developed and put in the right position within these standards. Here for this, for the IDS integration is this cross-system entity relevant, and here you can see how this integration with the ID connector has been done. So you have heard in the first presentation that I specification propose attribute-based access control. If we talk about data sovereignty, then we have to take into account usage control and data provenance with tracking, which is extension to the access control. And to do this, this is not trivial task. You can develop this for asset administration shell, but it would be better to reuse components and solutions provided by IDS Association, because they have already been used in several use cases, and they demonstrate the added value. And we decided to follow this approach. So we defined the usage policy in ODRL. This is Open Digital Rights language, and we use my data usage control framework to apply them by combining AAS and IDS. In the future, it can be the case that AAS policies will be formally defined, and that we have to map the AAS policies to IDS policies, or it can be also the case that the policy framework is defined for IDS, but in this case, the nice feature of IDS, like remote attestation, cannot be used. So here you can see how this integration has been done. IDS connector is placed in the cross-system entity. We have service container which contains isolated IDS application. We have IDS matches component which encodes and decodes message. So to transform IS message into IDS message in both direction. And here is a very important aspect that of IDS, that data resides inside of IDS connector, because the usage control framework can control the data usage. If the data leaves the connector, then it's difficult, very difficult to enforce the correct usage. If we talk about real application, industrial application, it is not realistic to expect that company always run all their software inside IDS. Therefore, we decide to provide support for combined solutions. So we are able either to deploy the whole digital twin inside IDS as an IDS application, or we are able to do this only for a subset of IDS services, for example, for services which deal with highly critical data. And we think that this solution would be good for the most of application. And here you can see one example of where this combination IS-IDS has been applied. This is a use case for a coffee provider with an automatic sorting machine, and the sorting machine is capable to separate desired from undesired beans based on the size of bean, based on the color on the bean. There is a sensor which is used, a camera which is used in real time. And here in this use case, we have asset administration shell for the sorting machine, which is connected with the sorting machine via OPC-UI protocol. But the communication with the customer, which is a consumer of these coffee beans, is done via IDS. So the customer should be able to place order. So there is a user interface to place the order, and the customer can specify how many, the amount of coffee beans to buy, or also the quality of the beans or the roast level of this bean. And he once the order is done, or during the order, the customer should get information about the total progress, about number of rejected coffee beans, or some other details. What is important for this use case that we have here several asset administration shell. We have asset administration shell for table sort, but we have also asset administration shell for coffee beans, and these asset administration shell are created automatically. Once the customer send the order, we here on the provider side have AAS registry with AAS for different types of coffee beans, and we will use this asset administration shell to create asset administration shell instance for the given order and deploy this asset administration shell on the client's side. And for the communication between customer and the provider, we have defined the usage policy. And in this case, the usage policy includes restrictions, so the data can only flow to visualization application, and that is visible only for a certain amount of time, so during the processing of this order. What I would here I would like to mention that our FAAS system is not only the library to create digital twin. It's not only the registry to register this digital twin. We have also developed a set of tools to support domain experts to deal with different with digital twin. And on this slide you can see our methodology to create digital twin. So you can start with identification when you have to clarify the asset for which you want to develop digital twin. Then you have to model this digital twin. The result of this model is AAS type 1. Then you have to create software representation of this digital twin, asset administration type 2 or type 3. Then you have to share this register, this asset administration shell in order to be accessed, to be reused, and possibly customized. Then you have to place digital twin in context to be used, and finally you have validation. And in order to support different phases of in the management, in the creation of digital twin, we have created a set of additional tools which help domain experts to do that. So we can start with capability questionnaire. Questions. It's not a tool, but it's somehow guidelines for domain experts to decide for which asset they would like to develop a digital twin and what level, and also what kind of services are needed. Then we have to model digital twin. We can model a digital twin by using IS Explorer, what we already have seen today, but also there are different possibilities to model the digital twin, for example, by instantiation of digital twin for a concrete machine can be created by digital twin of machine type. So in this way, we can speed up the modeling of digital twin. So we have a digital twin for very complex use case when you have to combine different digital twins. So digital twin of a machine can be created by combining the digital twin or all its components. Then what we did here, we have two tools which help us to create this model. We have OPCUA crawler, which allows us to create IS representation of OPCU information model, and OPCUA mapper, which allows us, for example, to extract information for Excel files. So we have a list of the product, and we would like to automate creation of asset for each product in this list of the product. Then to develop digital twin, we have IS service I have presented in the very first slide, but we also would like to generate IS based on different kind of data. So you can generate IS based on the model, but you also need some configurational data to do this, and the configuration is, for example, what kind of interfaces to offer to external services, what kind of caching strategy to apply for the data, and similar. So we have developed these tools for the configuration. Then we have the registry to register digital twin. The registry is also connected with the IDS broker in order to support finding digital twin from both perspectives. Then we have a component for visualization, which allow domain expert to specify which part of asset administration should be visualized and which means. We have a digital twin manager, which allows us to start to stop digital twin, and also to log all integration with the client, with the user. And we have fast client to allow integration of our software in external system. And here is my last slide. So I would like to mention IDS industrial community. The goal of this community is to bridge the gap between different initiatives like IDS, like Platform Industry 4.0 or GAIA-X. And if you would like to join, you can send mail to the mailing address you can see on this slide. Our next step is to clarify the use cases where all these initiatives make sense, and also to align different architecture. And on the website you can download our position paper on that. So thank you very much for your attention.
Okay, Liliana, thank you very much. I think I'm okay. I don't know why. Okay, maybe it's your. So thank you very much, Liliana, and sorry that we took a bit of more time than we anticipated. We can open a short period of question and answers if people have some questions and answers. I saw that Kiel has been asking some questions quite related to standardization. Andreas had to leave because he had a personal matter that he needed to attend, but we are here. So if anyone wants to ask some question, he can raise the hand, he or she, and then I can give you the floor to talk and to ask that question. Okay. I think if that maybe, let me see if. Okay. I don't know if, and I don't see if anyone has a question. Maybe if there is no questions, we can then catch up via email, but I'm just fear that it's just me that I'm not seeing the questions. I hope everything is okay. I don't know. Okay, we had some questions regarding standardization. I can give you the mic, and you can open your mic.
Yeah, can you hear me?
Yes, indeed.
Yeah, you know, excellent presentation and a lot of good work that have been done in this project. My question is really related to, you know, the definition of a digital twin, you know, that goes beyond collection a lot of sensor data to an asset. And within the ISO community, there are several initiatives to also connect directly back to the simulation data. And and also what was mentioned earlier, bill of material data and so forth, right? So what I'm interested to learn is how you envision that, you know, bill of material data, part number, you call it semantic identification, and so forth. But more importantly, how can we connect to this simulation data, right? If you have created a CAD model and a simulation model and you have a lot of sensor data, how can we ensure that this concept also provide the feedback to the, let's say, the as designed model, where you have a lot of maybe load cases, meshes in your 3D simulation model. So you have let's say an operational feedback. So you have a fully standardized digital twin, not only on the data collection, but also on the simulation aspect. So obviously ISO 10333 have the foundation to store all the simulation data. So we need to work on this subject because we have to make it even further more user friendly, where people can upload a CAD model, simulation models, and directly connect to whatever you guys have developed. So that is maybe more a remark than a question. Yeah.
I don't know if Sadia wants to give an input, because they are the ones that are doing this kind of work on the bill of quantities and bill of materials.
Yes, maybe I have an answer. Yes.
Sure.
Okay, so in a set administration shell, you can define several submodels. You can have a submodel for the simulation, and that will contain the CAD model, and the submodel for the operational data.
I understand, but they're not standardized, right? So we need to put in the standard context.
but you can put some standardized data into the submodel.
Yeah.
And you can create the relationships between the operational data and the properties that are standardized inside the simulation submodel.
Yeah.
So this may be an answer.
Yeah, Yuri, I think so also, but there is one specific point that I'm looking for, because if you have a simulation model, right, you put a sensor on a specific X, Y, Z vector coordination, right, and you should then automatically direct this information from the simulation model to your infrastructure. So that there is a small gap, but we need to find a solution for it. You know, we don't find it today, but we need to work on the subject.
Yeah, I agree. Yes, there are some pointers, but yes, we need to work on it. Yeah.
Yeah.
Very good. So, any more questions? Of course, you can send me or any of the speakers questions after, and then we can follow up via email. Of course, all of these presentations will be made available, okay, for starters, and of course the video will be also made available. I think okay, Angela is going to leave. Thank you very much. If you don't have any questions, we can close the webinar here, okay?
Thank you, Pedro.
Thank you, Pedro.
Very good. So thank you all for attending this webinar. We want to have more webinars on other subjects. So let's see what kind of technologies and new technologies and hot technologies are there that we will also address with very practical webinars, as you saw today, right? So yeah. Content, but then very practical, showing toolkits and projects and activities, really practical. So hope to have a good weekend to all, and the summer break also for the ones that might be going on vacations already quite soon, okay? Bye-bye to all.
Thank you, bye-bye.
Thank you, bye.
Bye-bye.